If you were absent on the 16th of May 2013, this was your whiteboard. And the whiteboard, you'd want to stop the recording and copy that down now. The first thing that I did in class, after everybody had a chance to get things copied down, was to look at primary, secondary, and tertiary lesson that we did yesterday. And this was a review, so I'm going to go kind of quickly on this because it's in yesterday's recording also. But here we have an example of a primary alcohol. Primary because the hydroxyl group sitting right here is hooked to one carbon, or the number one carbon in this particular guy, but the hydroxyl group hooked to the carbon is only touched by one other carbon, which means he's connected to only one other carbon, and that makes him primary. Primary refers to one carbon hooked to the carbon that's hooked to the hydroxyl group, and one is primary. Here we have two carbons hooked to the carbon that's hooked to the hydroxyl group, and there's 1, 2 here. The hydrogen doesn't mean anything other than this carbon was also bonded to a hydrogen. Over here on tertiary, here we're hooked to 1, 2, 3 other carbons when we're looking at the carbon hooked to the hydroxyl group. And so everything is in relationship to this carbon, which is hooked to the hydroxyl group, telling us how many carbons are actually hooked up to that particular carbon. So that was our little review on the hydroxyl groups and their making primary, secondary, or tertiary alcohols. And then your number 60, you've got primary, secondary, and tertiary alcohols in the discussion that we just had at the beginning of this tape, or this recording. And number 61, you have a 1-pentanol, and just to help you with the primary, secondary, tertiary, I'll label these and orally. And now you see the carbon that's hooked to the hydroxide only has one carbon hooked to him, and that makes him a primary. So this is also a primary alcohol, and his full name is 1-pentanol. Okay, here in letter B on 61, we have a 4-carbon chain. That's the longest chain, and that's a 2-methyl 2-butanol. 2-methyl because methyl is on number 2. 2-butanol because this guy, the carbon here, or this hydroxyl group, I'm sorry, is hooked to carbon number 2. And this becomes carbon number 1 because this guy is closer to this end than he is to this end. And this is a tertiary alcohol because the carbon hooked to the hydroxyl has 1, 2, 3 carbons hooked to him. As we go down to letter C, you'll see a 3-pentanol, and pentanol because we have 1, 2, 3, 4, 5 carbons in the chain, and our hydroxyl group is on number 3. So 3-pentanol. Okay, this is a propane, or a propanol, I should say. Propanol with the hydroxyl group on carbon number 1, and whenever that happens, the carbon hooked to the hydroxyl group will only be hooked to one other carbon, which makes this a primary alcohol. 1-pentanol, and this guy is hooked to an N carbon, so this carbon is where the hydroxyl is, and there's only one carbon hooked to him, so he's a primary. Now the second guy is a secondary because the hydroxyl group is on carbon number 2, not because he's on 2, but because there's 1, 2 carbons hooked to that carbon that is hooked to the hydroxyl group. And so we call that 2-pentanol. And then we have a 3-pentanol, and this guy is where the 3 states where the hydroxyl group is, and the pentanol refers to a 5-carbon chain. Now if I move this hydroxyl, by the way, if I move this guy over here, this is not 4-pentanol. This is 2-pentanol. Why? Because now the hydroxyl group here is closer to this end than he is to this end, so this becomes carbon number 1. Let me put that back so we don't confuse the next class. All right, and our last one of these, is this the last one? Let's check and see. Yeah, that's the last one. So 3-methyl, 3-pentanol, the methyl is on 3, and this hydroxyl is what determines which carbon is 1, but since he's in the middle, it really doesn't matter. So this could be carbon 1, or this could be carbon 1. So that was it for the homework. Next, we talked about how to identify the aldehydes, and more importantly, how to determine where carbon number 1 is. So let's first of all look at the ending. The ending for all aldehydes is going to be an Al. So the next thing is, where's the carbonyl group? If he's on the end of the chain, he's an aldehyde. Carbon from the carbonyl group is always going to be number 1. So that takes care of aldehydes and how we're going to number the chains that we have an aldehyde for. Next, we talked about how to do a ketone. The name for ketones always end in ONE. The carbonyl group will never be at the end of the chain, and the carbon from the carbonyl group will never be carbon 1. So if you have a carbonyl group on carbon number 1, you know you don't have a ketone, you're going to have an aldehyde. So it's never going to be on number 1. And that's our ketones. Now let's look at this side by side. Kind of helpful, I think, where the aldehydes have an Al, the ketones have an ONE on their endings. Carbonyl group on the end of the chain, carbonyl group never on the end of a chain. And then on aldehydes, the carbon from the carbonyl group is always on carbon 1. On the ketones, carbonyl group will never be on number 1. And from there, we went to seeing some examples. So let's look at those and return to single frame. And let's just get these covered up for now so that you can actually go along with me as I go through the naming of these guys. Here's an aldehyde. How do we know he's an aldehyde? We see that our carbonyl group, which is the carbon with a double bond O, is sitting on the end. That's the dead giveaway. So this becomes carbon 1. Now the thing that is not real obvious about this particular molecule is it looks like we have an ethyl group here and an ethyl group here, when in reality, as we count the chain, if we go 1, 2, 3, 4, 5, 6, we think we have a hexanal, but we don't, because if we count the chain 1, 2, 3, 4, 5, 6, 7, that means that we really have a heptanal. So now we have to determine what the substituents are. And it's probably nice to go ahead and write in the numbers. So this is 1, 2, 3, 4, 5, 6, and 7. And this guy here, you see, is on the end, making it a heptanal. And as we look for our substituents, let's go ahead and circle those in a different color. We have a methyl here, we have an ethyl here, and we have another methyl over here. So it's very different than the way it looked at the beginning. So as we name this guy, we're going to start out with 3 ethyl. So the ethyl is sitting here on carbon number 3. Next we have a 2,5-dimethyl. 2,5-dimethyl because the first methyl is sitting here on number 2 and the second methyl is sitting here on carbon number 5. And so that's why we have 2,5-dimethyl. You see, up to this point the naming is just as if we were naming an alkane. and this is not an alkane. Of course, it's an aldehyde. So our ending determined by, I'm sorry, the name itself determined by having 7 carbons would be a hep, and it's a heptan al. And why is that? Because the ane ending that is common to the alkane becomes a ANAL, the AL ending instead of the E. And so we just take off the E from the ane and add the AL for the aldehyde ending, and that's how we get our heptanal. And then our next little dude down here, you need to know a little bit about halocarbons. And halocarbons are those guys that are going to have some halogen hooked into the chain. Halogen is column 17 on the periodic chart. So chlorine would come in with the name of chloro, and iodine comes in with the name of iodo, and bromine comes in with the name of bromo. And the last halogen that ends up in any of these guys with any degree of regularity is fluorine. That would be fluoro. So when we name this guy, we're going to put our halogen substituents in alphabetical order. So we have a bromo on carbon number 4. And let's go ahead and put in those numbers. 1, 2, 3, 4, 5, 6, 7, 8. So we have a octanal, and that's going to be the final name that we put in there. At any rate, we've got our bromo taken care of. He was on 4. Now, next in alphabetical order is we're going to be on carbon number 6 with our chloro. And then we're going to be on carbon number 5 with our iodo. And of course, methyl is on number 3. So methyl would be after the halocarbons. Okay, and the overall name, octanal. Notice there's no number in front of octanal, nor was there any number in front of our heptanal, because with an aldehyde, the aldehyde, or the carbonyl group, this guy, is always on carbon 1, so we don't need to specify it. Everybody knows that. Now let's look at some ketone examples. With ketones, you have the, my first example will have a total of 4 carbons on it. 1, 2, 3, 4. And since this is a ketone, we can name it in 2 different ways. Now, if I look at the carbonyl group, this guy right here, as being my longest chain, and think of these guys, which I've underlined in green, as being their substituent, then it becomes real logical to think of this as ethyl-methyl ketone. Ethyl for this guy, see, 2 carbons. Methyl for this guy, only 1 carbon. And it's a ketone because this carbonyl group is in the middle. Now, there's another way to name these guys, and that would be to call it a 2-butanone. And the O-N-E for a ketone, and the but because there's 4 carbons in the chain, if we look at it that way, and the double bonded O becomes kind of like a substituent on number 2. But it's because this is a functional group, we're referring to it as the functional group, and it's in the number 2 position. And that's it for naming a ketone. Let's do another one, because there's always going to be a possibility of 2 names here. So let's first of all look at the chain here. If this is the longest chain, then on this guy I have an ethyl and I have a propyl. And so we could call this, as I have here, ethyl propyl ketone. Ethyl propyl and the ketone because the carbonyl group is in the middle. And then if I wanted to name him, this would be carbon number 1 with a systematic name because the carbonyl group is closer to this end. And so we would have a 3 because this little dude's on carbon number 3, and it would be a 3-hexanone because there's 6 carbons in the chain. And that's it for naming the ketones. I hope you find this helpful.